calculate the critical depth and the corresponding specific energy for a discharge of 4 meter cube per second in a rectangular channel of width 2 meters and in a triangular channel with side slope 0.5. Now, critical depth corresponds to minimum specific energy. The condition of minimum specific energy is known as critical flow condition, and the corresponding depth is critical depth. Critical flow condition also corresponds to the condition for maximum discharge in a channel for a fixed specific energy. Let us say the specific energy is fixed here. Now this fixed specific energy will correspond to a condition for maximum discharge. Okay, so this is the point where the specific energy is minimum. Okay, and there will be only one depth at this point. Okay, now as we go towards the right, there will be two depths. These are called alternate depths. Okay, but at this point there will be only one depth. This depth corresponding to minimum specific energy is the critical depth. Now, for a rectangular channel, critical depth can be calculated using this condition: Yc is equal to q square by g raised to 1 by 3. First of all, let me show you this specific energy diagram. Okay, x-axis shows specific energy, and this is the corresponding depth. Now, specific energy and depths have been calculated for this rectangular channel, okay, in which 4 meter cube per second of discharge is passing. Now width of the channel is 2 meters, so specific energy, which is equal to y plus v square by 2g, can be obtained for different depths. Okay, as you can see, a point will come where the depths will converge. Okay, a single depth 0.74 for specific energy of 1.11. This is the critical depth. Okay, so specific energy will be minimum for this discharge, okay, at this point. In case of triangular channels, specific energy y plus v square by 2g. In this case, area is taken as A is equal to m into y square. M is the side slope and y is the depth. And A is equal to my square was used to calculate the velocity. It was used in this equation to obtain specific energy corresponding to different depths. Okay, and minimum specific energy in this case is 2.089, and the corresponding depth is 1.67. Okay, specific energy is equal to depth y plus velocity head. Okay, so these are the values of velocity head and these are the values of depths. We are interested in minimum specific energy and critical depth. So a direct relationship to obtain critical depth is this: Yc is equal to q square by g raised to 1 by 3. Okay, so you'll get the value of critical depth equal to 0.742 meters, and specific energy at this point is EC is equal to 1.112 meters. Okay, so if we put the value 0.742, we will get the specific energy equal to 1.112. Okay, Now in case of triangular channel, critical depth can be obtained using this equation. Yc is equal to 2q square by gm square raised to 1 by 5. Now there's one more thing I need to point out, is that q is the unit discharge. It is meter cube per second per meter. So it is equal to uh, discharge divided by width. Okay, so we used unit discharge in this equation. Okay, but in case of triangular channel we'll be using this capital Q, which is given in the problem, 4 meter cube per second. Yc is equal to 2 into q square by g into m square raised to 1 by 5. So it will give us the value of critical depth 1.672 meters, and the corresponding specific energy is 2.089, okay, which can be obtained using this equation. Ec is equal to 1.25 into Yc. Okay, as you can see, the values have been arranged from large to small. They are arranged in descending order. So you can see this is the minimum specific energy 2.089, and the corresponding depth is 1.67, okay, which was obtained using this equation. Okay, and the corresponding specific energy is 2.089. So for rectangular channel, the critical depth for a discharge of 4 meter cube per second, okay, is 0.742, and for triangular channel with side slope of 0.5:1, the critical depth is 1.672 meters. Okay. So for rectangular channel it is 0.74. For discharge of 4 meter cube per second. Okay, and critical depth for triangular channel is 1.67 meters for discharge of 4 meter cube per second.